My name is Ray.
Hi, this is Michael.
Welcome to our episode of Race Economics Clue Book. Today, talking about the long-term average total cost curve and economies of scale that result from it.
Okay.
So last time we stressed about short run. This is because in the short run we can't change our average fixed cost or AFC.
Sure.
Basically, our fixed costs in general we can't change, like land or utilities, things like that. You can't change. You're stuck with that at least for a month. Or
Yes.
Or at least until the next bill or the next deal comes along. And so your average total cost is basically what exists in the short run. The average real cost, obviously, it can vary in the short or long run no matter what. And so this is our cost curve is basically derived in the short run from the last video. But in the long run, what's different is that fixed costs can be changed in the long run.
Yes.
And they can also, once you can change your fixed costs, you can adjust that in order to have an optimal or minimize your average total cost curve at every single output level.
Yeah.
It's just basically the entire curve shifts to a lower level. Shifts down.
Yeah. Remember, the ATC means total cost divided by output.
Yeah.
Okay. So when output increased faster than your total cost, okay, then ATC goes down.
Yeah.
Right. Okay. Because total cost equals variable cost plus fixed cost.
Yes.
Okay. So as long as if fixed cost increased in the long run, as long as output increased faster, we actually get benefit. Right. So
because long run fixed cost can be changed, and that this can also change or lower average total cost curve, this leads to the conclusion of a long run average total cost curve, which exists. Here, the blue line here represents the long run total cost curve. The long run total cost curve, of course, consists of many different short run average total cost curves that are a part of it, which are the yellow lines here. At the very left, at low output, right here, the yellow curve here represents the average total cost in the short run for a smaller factory of lower output. Then as we increase output, we see that our average total cost curve shifts down because our long run average total cost decreases. And so for the average total cost of a medium-sized factory is the one in the middle here. And then on the far right is average total cost curve for a large factory for large production. Of course, it picks back up because the long run average total cost curve in the blue is still like a U shape. At first it decreases, and then it stabilizes and increases. When it decreases, it's called an economy of scale.
Yeah. So basically, we can see actually long run ATC is very similar with short run ATC, except it's much wider.
Yeah.
Okay. And the reason is because when we output from low level to high level to medium level, we have an economy of scale. Why? Because from small factory to medium factory, maybe our fixed costs increase. Now we have a different output, our fixed costs increase. But remember, ATC equals average total cost equals total cost divided by output. So as long as our total output increase even faster than the fixed cost increase, our ATC goes down. Right? So basically that's what we call economy of scale, which means actually we gain more efficient. So which means, for example, we double input, right? Double our fixed cost. But we can triple output, for example. Okay. Now, so we gain efficiency. So our output increase even faster than our input cost. Okay. So that's why we see that ATC actually goes down at each output level. We have a short run ATC, and our long run ATC apparently is the combination of the lowest point of the short run ATC. But as Ray just mentioned, the story cannot always go this positive always. When our output goes higher, what happened?
Output goes higher, we see an average total cost curve in the long run increase because we have the same rules that apply to short run total cost curve. They play here. Where at extremely large quantities of output, we have essentially crowding occurs, decreased efficiency occurs, and so in the long run, even if we can adjust our fixed costs, no matter what, is inevitable that our ATC, our average total cost, increases at high levels of output.
We call that actually exactly opposite. We call that diseconomy of scale. Which, for example, we double input, maybe our output does not change at all, right? Because of what? Because of bureaucracy, for example, very difficult to manage, right? Communication problems and so forth. So we're going to see the next slide. So here.
And so basically, we have an economy of scale because At lower to medium levels of output, we have increased specialization that occurs with more input, with more output as well, with an increase in size in general. Because when we first start out, we have a large initial fixed cost to get first and foremost, when we're first starting out our company, starting out our factories, the initial fixed cost in labor or utilities is still very high relative to our income and output. However, as we increase in size, increase in revenue, increase in output, the fixed cost is diluted because compared to our current size, the relative size is now decreased. We also have network externalities that are existing at low to medium levels of output, which is at first when we're growing as a company, growing in our output, we have our increased popularity leads to even more popularity, or attracts even more consumers. Or increased popularity strengthens our efficiency in our company size and output production. And so this is an externality that occurs when our network of the company increases. A positive externality. This is externalities, of course, are a very important part of economics that we'll also still talk about. For instance, auto plants, right? Auto plants, when we first started, we have a very large initial fixed cost for auto plants, but eventually, as our auto plants increase in size, increase in specialization, and efficiency per input, because at lower levels we have increased input efficiency. The auto plant's fixed costs are more diluted as it increases in size and efficiency, and it has externalities that occur, positive externalities that occur from its growing network. However, we have a diseconomy of scale for the opposite reasons. We already mentioned the communication become more difficult. Efficiency goes down, which means more than double the input probably results in nothing happening in output. For example, on an overcrowded road, if we go too many gas stations, right? The first two gas stations are very efficient. They rake in a lot of sales. They communicate easily. However, you put 10 gas stations on one road, eventually the communication is going to be more muddled, and efficiency or revenue per gas station is more diluted or does decrease in general. So per unit efficiency is decreasing, and of course our average total cost is increasing at high levels of production, leading to a diseconomy of scale. Then that's just a metaphor. And so for final clues, basically the key differences in long term is that a fixed cost is variable in long term. We can adjust our fixed costs like land or utilities, things like that. And so long run average total cost curve is a combination of the lowest points of short run average total cost curves at each output level. The rest, long run average total cost curve are of course made up of short run average total cost curves that are adjusted per output and per fixed cost. And so a long run average total cost curve shows a transition from economy of scale to diseconomy of scale. As you see here, economy of scale, diseconomy of scale.
It's just much wider. It's a combination of all the different short run ATC curves lowest point at each output level, and it's actually much wider and like a very big smiley face. Alright, so today we're gonna just finish that here and see you next time. Bye bye.